As ice melts and aquifers are drained, Earth's distribution of mass is changing, and with it the position of the planet's spin axis. The collapse of Antarctica's Larsen B ice shelf in 2002 is just one example of shrinking glaciers around the world, a process that is changing the planet's mass distribution. Finding the North Pole means traveling north, right? Yes, but with a slight caveat. Earth's northern pole is drifting rapidly eastward, and it looks like climate change is to blame. The discovery may have major implications for studies of ice loss and drought, potentially improving our ability to predict such changes in the future. Earth turns around an axis like a giant spinning top. The places where that invisible axis intersects with the planet's surface are the north and south rotational poles. Due to Earth's wobble on its axis, these spots drift in roughly decade-long cycles. All this motion is a completely separate mechanism from the behavior of the planet's magnetic poles, which also reverse periodically over the course of millions of years. Scientists pinpoint the geographic north and south poles by taking the long-term averages of those rotational positions. Explorers and scientists have been reliably measuring the precise positions of the rotational poles since 1899. First, by measuring the relative positions of the stars and then by using satellite telemetry. Over the past century or so, the poles have tended to wander by just a few centimeters a year. That may seem like a tiny variation, but there is very important information embedded in that, says Surendra Adhikari, an Earth scientist at NASA's Jet Propulsion Laboratory in California. The North Pole has shifted back and forth from east to west, with an overall trend that had it moving toward Canada. But since 2000, the pole's typical drift has made a dramatic change, says Adhikari. Since that time, the pole has been moving steadily eastward by about 75 degrees, heading toward the prime meridian that runs through Greenwich, England. This shift has been on the order of 10 centimeters a year, so it's probably not enough to warrant a recalculation of the planet's geographic pole, although later generations may have to consider it if things keep changing, notes Adhikari. What's most exciting to the scientists is that they can now explain what's actually causing the drift, and that may have significant ramifications on climate science. Ebb and flow. For at least a decade, scientists have suspected that the massive amounts of melting taking place in glaciers around the world could significantly redistribute mass on Earth. That's particularly true when it comes to the huge ice sheets over Greenland and in the West Antarctic. If ice disappears from one part of the spinning Earth and resettles elsewhere as water, the planet shifts on its axis toward the place where it lost mass. But the physics are so complex that scientists could only guess at how this actually works in the real world. Now, Adhikari has proposed a way to explain the process. The secret was discovering that it's not just shrinking glaciers that change Earth's mass distribution, as some scientists had thought. A lot of mass also gets moved around due to large-scale loss of liquid water from the land. The team reports this week in Science Advances. Adhikari and his colleague and co-author Eric Evans think the rotational pole is shifting toward Europe because there has been a massive loss of water from lakes and aquifers in Eurasia, around the Caspian Sea, and in India. Warmer temperatures overall have led to more evaporation and less precipitation in many areas, and booming human populations have been sucking up groundwater from reservoirs and wells. Watch Saudi Arabia get drained dry. What we have shown is that melting ice and a pattern of continental water storage are combining to cause a dramatic shift in the direction of the pole, says Adhikari. Gavin Schmidt, a climate scientist with NASA's Goddard Institute for Space Studies in New York, commends the authors for adding to the discussion about climate science. Schmidt, who is not affiliated with the study, agrees that human activity has caused detectable shifts in mass from ice sheet melt and groundwater extraction. Earth's North Pole is slowly moving towards London, and scientists have finally figured out why. Earth's North Pole has never been as stable as it looks on maps, with the planet wobbling slightly as it spins on its axis, and causing the poles to gradually drift. But 15 years ago, around the turn of millennium, the pole mysteriously switched direction and started heading east towards the Greenwich meridian at almost twice its previous speed. And now NASA scientists have finally figured out why. For the better part of the 1900s, the physical North Pole was moving westwards around 10 centimeters each year towards Canada's Hudson Bay. But in 2000, it shifted direction 75 degrees eastwards and started moving east at a rate of around 17 centimeters annually, an unprecedented and unexpected move. It's no longer moving toward Hudson Bay, but instead toward the British Isles, said one of the researchers, Sharindara Adhikari from NASA's Jet Propulsion Laboratory. That's a massive swing. But if the knowledge that the North Pole is gradually moving towards London is surprising, perhaps slightly less shocking is what's behind the shift. After studying satellite data, the NASA team found that humans are pretty much to blame due to our influence on the planet's water content. Adhikari and co-researcher Eric Evans used data from NASA's GRACE satellites to see whether water mass across the planet was related to Earth's spin axis, and found an incredibly strong link. In fact, the influence was so large that when they used the changes in land water mass to predict the positions of the North and South Pole between 2003 and 2015, the results perfectly lined up with the real data. This is much more than a simple correlation, said Evans. We have isolated the cause. Before this, it was assumed that water was playing a role in some way, but most of the blame was put on climate change and the melting of the Greenland ice sheet. But Adhikari and Evans showed that the changes in Greenland alone weren't generating enough energy to pull Earth's spin axis so far to the east. They calculated that something east of Greenland had to be exerting an extra pull to move the North Pole as much as it had, and that something was happening in Eurasia. The bulk of the answer is a deficit of water in Eurasia, said Adhikari. The Indian subcontinent and the Caspian Sea area. The water lost in this region between Europe and Asia doesn't even come close to the changes happening up at the Arctic ice sheets. But the team found that the spin axis is particularly sensitive to changes occurring around 45 degrees latitude, both north and south, which is why the changes in India, for example, are so important. The good news is that the Earth's swabble doesn't really affect our daily lives at all. And as far as we know, the furthest Earth's North Pole has ever moved is 12 meters, 37 feet. But we do have to take into account the shifting poles to make sure GPS is accurate, and this model will help us do that. Not only that, but finally knowing what is controlling the direction and movement of the poles means we will now have more insight into the water content of Earth than the past, and can begin to predict the poles' movements well into the future. Is it true that the Earth's magnetic field is about to flip? Like football teams at halftime, geophysicists think that the Earth's magnetic poles could soon switch ends, with the magnetic North Pole becoming south and the magnetic South Pole becoming north. Fortunately, when they say soon, geophysicists are thinking in geological timescales, and they actually mean sometime in the next few thousand years. It's thought that the Earth's magnetic field is generated by the molten iron core at the center of the planet. The molten iron has currents of its own, just like an ocean, and these moving currents create the magnetic field. But the currents are not consistent, and the Earth's magnetic field moves around, with the magnetic North Pole currently drifting by about 10 miles a year. Poles flip completely, but this movement of the field is small compared to a complete flip, so what is there to suggest that one is imminent? Geophysicists have been studying the lava that was seeped up from the core and through a ridge on the floor of the Atlantic Ocean. As lava cools and solidifies, it preserves the direction of the Earth's magnetic field, so looking at the rock that has formed over time gives us an idea of what has happened to the magnetic poles in the past. These studies show that the poles switch ends every 500,000 years or so, and that we're due for another switch in the next few thousand years. There's also evidence to suggest that before the Earth's magnetic poles switch, the magnetic field slowly fades out before reappearing with the poles reversed. And our magnetic field has depleted by 5% over the last century. Volcanic eruptions so large and widespread that the resulting ash clouds and gases could blanket the sun's rays and trigger a new sudden ice age. Scientists look for evidence of previous Armageddon-style destruction by identifying chaotic sediments where narrow layers of earth, rock, and ice record oddball events in the Earth's history in the form of bands of mud and tiny magnetically charged fragments. To scientists, these are clear indicators of sudden floods, ice melt or ash deposits. When this is found outside a long period of the cycle of freezing and melting in the Earth's history, it is an indicator of a pole shift. Pole shifts cause a major increase in the movement of the tectonic plates. The giant lines of opposing cracks in the Earth's crust which push and grind against each other until they periodically release like a balled fist in a closed palm flicking upwards. There are now signs amongst the sharp increase in natural disasters and other strange, apparently unrelated incidents which point towards a possible reversal. It is widely recognized that magnetic north, that point at the top of the globe, which compasses and devices which depend on magnetic navigation rely, is shifting increasingly quickly towards Russia from its current position above Greenland and nearer to Canada. It has moved 400 kilometers in the last decade and is accelerating. Our sun swaps its north and south pole every 11-13 years and has just done so. The effect on the sun is to stimulate the number and intensity of solar storms which can have a major effect on the Earth. They can interfere with TV transmissions and power supplies. Other signs which might indicate the effects of a magnetic reversal between magnetic north and south are an unprecedented 7 volcanoes which have started to erupt around the world in the last few days, and a major spike of 7.0 magnitude plus earthquakes, almost all of which I have witnessed personally a few days after the event as a documentary maker. The cycle started in Indonesia in 2004 and occurred again very recently in Nepal. These sharp increases in seismic activity do occur every 30 years or so and may be part of a natural ebb and flow, but they are another aspect of what could be a major trend in the light of the relentless and quickening march of magnetic northeast away from its original position. Pole shift _Renal plus National plus Park. USGS U.S. and NASA are very concerned about a new magma chamber the University of Utah have discovered recently under Yellowstone National Park, in addition to the enormous lake of molten rock and iron they already knew about. This one is an astonishing 11 times the volume of the Grand Canyon. A sudden pole shift could become the push the magma chamber with the surface area of Los Angeles needs to blow up. If it does, most of North America would be destroyed instantly and a new ice age would begin. Another story which begs the question what on earth is going on is a 300-meter, 900 feet high island which has appeared from the seabed just north of the tip of Japan in just one night. This area was the origin of the 8.9 magnitude earthquake which ripped through Japan in 2011, causing one of the worst tsunamis of all time. Sections of crustal plates which suddenly move under enormous heat and pressure which cause earthquakes and tsunami have been known to move dramatically, although it is often never seen as it occurs miles down on the seabed. A new shelf 800 kilometers 500 miles, and 60 meter, 180 feet high, appeared off the west coast of Indonesia in 2004, which triggered the infamous tsunami wave which swept completely around the Earth's circumference 3 times. The new Japanese landmass appeared at almost exactly the same time as the Nepal 7.7 magnitude earthquake took place 5,000 kilometers, 3,000 miles, away at the opposite end of the Eurasian tectonic plate. Finally, the weirdest account of nature behaving strangely are reports of a strange humming noise coming from the sea. Scientists have explained this as the effect of the currents running through the oceans. This is the effect